So on question 4, we're given two partial tables, and we are told that A is an arithmetic sequence. That means that we're growing by an equal amount for equal intervals. So every single time x increases by 1, the y values are increasing by the same exact amount. On B, we were told it was a geometric sequence, and we were asked to write an equation in the form y equals ab to the x that would fit this. So here we are multiplying by this common ratio. We're multiplying by the same thing again and again instead of a common difference. So let's take a look at this one first. Probably having the 5/3 here was a little bit intimidating, but what's happening is we have to figure out our slope, right? And remember that the slope for an arithmetic sequence is the same as a slope for a line, right? It's the amount that y changes, so we need to look at the change in the y values and divide that by the change in the x values. So our y values go from 5/3 up to 3. And if I want to figure out how much of a change that is, I can take 3 and I can subtract 5/3. And without using a calculator here, I'm going to turn 3 into thirds. So that's the same as 9/3 minus 5/3, right? 9/3 is exactly the same number as 3. So I've replaced 3 with something that's equivalent to it. The nice thing now is I have a common denominator here, and I can do the subtraction. So 9/3 minus 5/3 is equal to 4/3. So this y value changed by 4/3. So I know my change in my y, it's 4/3. But I need to figure out what change in x is. My x value is at 1, and it jumped all the way to 5. So my change in x is simply 5 minus 1, which is equal to 4. So if I look at this, I'm dividing 4/3 by the number 4. 4/3 divided by 4 is what this is going up by each time. So a couple ways I can deal with this. One of them is if I'm dividing a fraction by a fraction, like 4/3 divided by, I'll write this as 4/1, same thing. This division of a fraction by a fraction is equivalent to the numerator, 4/3, times the reciprocal of the denominator, 1/4. So if I look at this, right, there's a common factor here of 4/4. 4/3 divided by 4/1 is equal to 1/3. Now, of course, right, you have access to your calculator. You could use that. You could figure that out. So the common difference is 4/3. And I really encourage you to think about rational numbers like this, fractions like this, because it helps with a lot of algebraic expressions, especially in the future. My common difference is 1/3. If I was to subtract 1/3, that would mean that this 0th term would be the number 4/3. If I add 1/3, I would get the number 6/3, which does reduce to the number 2, plus another third, but probably be just convenient, right? That would be 7/3. This would be 8/3. The next one would be 9/3, which is 3, so it's kind of a good check. So I've completed the table for this representation. I figured out the change in y and the change in x, so I can write the equation of it because I know the 0th term and my common difference. It is y equals 1/3, there's that slope, times x plus 4/3. And if I pick any one of those inputs, like if I put the number 5 in there, I should get 3. And as a check, I might do that. So if I put 5 in, that would give me 5/3 plus 4/3, which is equal to 9/3, which is equal to 3. So I can see that I just checked that one. And the other point I could check is, if I put 0 in, I get 4/3. So I'm pretty satisfied with that. So it's a line. We've been dealing with lines since 7th, 6th grade, right? It can be difficult to go from one representation to another, but just think about, what we do know, the fact that it's change in y, change in x, and try to find those things. And don't be afraid to use your calculator. It's not a problem if you struggle with arithmetic at all. I know I do. I struggle with arithmetic. The next one, there's two ways we could approach this. We could approach it as a systems of equations problem. We've done that. So for example, I could write the following. I could write 7 equals a times b to the first power. And I could also write 112 over 81 equals a times b to the fifth power. I could isolate a in both of those, and then I could go through and solve for both a and b. I'm going to take a different approach. I'm going to observe that I start with the number 7, and I multiply by a bunch of b's, right? In fact, that's what I know about, a geometric sequence is I keep multiplying by this common ratio. So if I have the number 7, I would multiply it by 1, I would multiply it by 2, I would multiply it by 3, and I would multiply by 4 values b. So 7 times a bunch of b's, 7 times 1, 2, 3, 4 b's, 7 times b to the 4th power is this fraction of 112 divided by 81. Okay, so I am definitely going to need a calculator for this, but here's what else I can do without grabbing the calculator yet. Maybe I don't need a calculator. Maybe I do. I don't know. I know that I'm going to divide both sides by 7. So I can say that b raised to the 4th power is 112 over 81. And that whole thing is over the number 7. So I have this fraction right now that's a little complicated. It's got a fraction in the numerator, fraction in the denominator. This thing, now if I want to figure out what my multiplier is, I'm just going to take b, and it's going to equal 112 divided by 81 all over 7. But I'm going to raise this now to the 1/4 power. Right? If I raise both sides of this equation, if I raise both sides of this to the 1/4 power, I know over on the left-hand side I end up with this b to the 4th, and when I raise b to the 4th to the 1/4, that equals b to the 1st. So that's what I've got here. I've got b to the 1st power. And this is going to let me figure out what b is. Now I need a calculator. I have to go grab that from my desk in the office. Just one moment. Unfortunately, I don't have my virtual calculator on this laptop, but I do have this calculator. So I'm going to go ahead and enter these values into here. And when I do this, and you've seen this in the classroom, it's 112 over 81, and then that whole thing is going to be over the number 7. And I'm going to take that result and I'm going to raise it, raise that to the 1/4 power. And when I do, I get 2/3. So b is the number 2/3. That's what I'm multiplying as I go each one of these steps. And I can get confirmation of that by taking the number 7, putting it on my calculator stack, and then going times 2/3. And when I do that, the next number I get is 14/3. And then if I multiply that by 2/3, I get 28/9. 28/9. Multiply that by 2/3, I get 56/27. 56/27. The very next term is a confirmation is 112 over 81, so that's a check. The next value after that should be 224 over 243. So I'm multiplying by 2/3 to go forward. What I'm going to do is I'm actually going to start with this number, put it on my calculator stack, and I'm going to divide by 2/3 to go backwards, and then that'll allow me to figure out what my 0th term is and just kind of double check these other numbers. So on my calculator stack, that just means one of the lines of display is I got 224 over 243, and I'm going to divide by 2/3. When I divide by 2/3, I got the one above, 112 over 81, 56 over 27, 28 over 9, 14 over 3, 7, and then the 0th term is 21 over the number 2, 21/2. So at this point, I know exactly what I need to do to go to this other representation, to go to the equation, and I'm going to write that down. I know that my 0th term is 21/2, which is a, right? That's what that parameter is. And I know that my multiplier b is 2/3, so I can write y is equal to 21/2 times 2/3 raised to the x power. So this is exactly the rule for this sequence, and it does give me the two values that I know. It gives me, if I plug 1 into it, it gives me 7, and when I plug in the number 5, it gives me 112 over 81. All right, so that was that question number 4, and let's move on.